This video is about the work done in isobaric process. We will see the derivation for work done in an isobaric process. What is an isobaric process? It is a process in which the pressure remains constant. We will consider two states. One, the initial state, and second is the final state. Let V1, T1, T1 be the initial state. Let V2, P2, T2 be the final state. So we can write down the work done in the isobaric process as W is equal to integration of P into dV with the limits from V1 to V2. We can take P outside the integral. So that will be integral of dV. If you integrate dV, you get V, and by substituting the limits, you will get V2 minus V1. So finally, this is the work done in an isobaric process, that is W is equal to P into V2 minus V1. Now we will see what happens in the case of an ideal gas. We will use the ideal gas equation PV is equal to RT, and we will use that for both the initial state and the final state. For the initial state, we can write down as PV1 is equal to RT1, and for the final state, you can write PV2 is equal to RT2. If you substitute now these equations in this equation of work done, you will get, this will become PV2 minus PV1, and now we will substitute this ideal gas equations. So that will be RT2 minus RT1. Taking R common, you get W is equal to R into T2 minus T1. This is the case of an ideal gas undergoing isobaric process. Now we will use the first law of thermodynamics. Q is equal to delta U plus W. Delta U is the change in the internal energy. So the change in internal energy will be written as U2 minus U1. U2 corresponds to the final state and U1 corresponds to the initial state. The work done W can be written as P into V2 minus V1, the equation which we have just derived in case of an isobaric process. We can write this now as U2 plus PV2. We can open, if you open this bracket, this will be PV2 minus P1. So that can be written as U2 plus PV2, that is all the terms in 2 we will put it in one bracket, minus U1 plus PV1. So all the terms in 1 will be put in another bracket. This we will write down, this U plus PV form we can write down as H. So this can be written as Q is equal to H2 minus H1. So we define here a thermodynamic function called enthalpy, that is given as H is equal to U plus PV. From this equation, Q is equal to H2 minus H1, we see that the increase in enthalpy of a system is equal to the heat absorbed. Hence, heat transferred during the process is represented by H. U, that is the internal energy, P, the pressure, volume, V, and the enthalpy H. They are all state functions. Thank you for watching my video.